Module 2 starts with the anatomy. Not tools yet, not retries yet, not the full agentic loop yet. First, you need to understand the basic exchange. Your application sends a request frame, Claude returns a response frame, and your architecture job is to decide what each field owns, what the response state means, and what the application should do next. That sounds simple, but this is where many people make the first serious mistake. They reason from the assistant wording. They look at the text and ask, does this sound fresh? Does this sound helpful? Does it sound like the final answer? That is fragile. The stronger architecture move is to reason from response state. Before you can routing deterministically, you need to know what state the application is actually receiving. So the promise of this lesson is simple. By the end, you will know how to read Claude request and response as application state, not just a text. That with one state request frame. A Claude messaging API call has several important fields. It has model, it has token budget, it has messages, and it often has system instructions, tools, and metadata. Build your understanding around field responsibilities. What does a model field own? It selects which Claude model handles the request. What does the token budget owns? It limits how much output the model can generate. What do messages own? They carry the relevant tune history and user visible conversation state. What do system instructions own? They define durable behavior, constraints, and boundaries. What do tools own? They describe callable capabilities and input contracts. What does metadata own? It gives your application tracing and support contexts. The key mechanism is that the API doesn't remember your prior conversation for you. Your application sends the relevant conversation state in the messages list each time. That means message history, tool results, and metadata are not side nodes. They are part of the application state you choose to preserve and resend. Now separate the responsibilities. System instructions are the durable behavior and boundaries. Messages are for the turn history and user visible conversation state. Tools describe callable capabilities and input contracts. Data is for your application tracing and support contexts. If a tool boundary belongs to the tool description, do not bury it only in the user messages. If a trace identifier belongs to metadata, do not rely on a node in a prompt. If a behavior rules should apply across the whole interaction, do not hide it in one temporary user message. Clear fields ownership makes later debugging much easier. Now let's look on the representation frame. The response frame tells your application what just happened. The response identifier gives you something to log. The content fields give you ordered content blocks. The usage field gives you token count. And the stop reason tells you why Claude stopped generating. The stop reason field is the bridge from anatomy to control flow. It is the field that tells the application whether it is probably a final answer, a tool request, a token limit, a pause, a refuser, or another state your application must handle. Current stop states can include normal completion, tool use, maximum token limits, stop sequences, pause turn, refusal, context window. Do not memorize that list as a vocabulary only. Use it as an architectural habit. Inspect the stop state before deciding what the application should do next. The next module will teach you the routing branches. For now, the habit is simple. Do not start from the text. Start from the response state. Tool use is the first place where assistant wording can mislead you. A response can include helpful text and still not be the final answer. For example, Claude may write a short explanation and also request a tool. If the stop reason is tool use and the context includes tool use block, the assistant is asking your application to execute something. The application should not declare the task completely just because the text sounds useful. The application returns the requested tool. It captures the result, then it sends a follow-up request with the relevant conversation state and the tool request. That is why the course keeps repeating the same line, wrote on state, not on prompt wording. Text can explain the request, but the loop should be driven by the response shape. Now let us talk about logs. Logs are architectural state. At this layer, you should preserve the facts that explain the run. Response identifier, stop reason, save tool name, save input summary, usage count, next action, and later any retry attempt and structured error category. There are the facts you need for debugging, support, and scenario review. The opposite matters too. Do not log secrets, do not log credentials, do not log unnecessary raw private data, do not log full documents, do not confuse logs with planning nodes. Logs preserve a running state. Architecture decision record explains why the decision was made. Different artifacts, different jobs. Now we move to the course download pack. Notice the first table. The request table is about ownership. Model, token budget, system instructions, messages, tools, metadata. These fields are the requests. What does the application send and what does each part own? Now look at the response table. The response table is about inspection, response identifier, content, model, stop reason, stop sequence, usage. These fields are at different questions. What happened and what should the application do next? Now open the lab 1 sample response. Here is the response identifier. Here is the stop reason. The stop reason is a tool use. This is already enough to tell us something important. This is not just the final text. This is a request to the application to do the work. Now look at the content blocks. First, there is a text block, then there is a tool use block, then tool use block has a tool name. It also has a tool input. In this sample, the tool asks for customer profile using a customer that gives the application the concrete next action. Now look at the usage field. Usage gives us the input token count and output token count that is useful for cost tracing and debugging. So the small sample response gives us enough state to declare the next action and log the trace. Response identifier, stop reason, content blocks, tool requests, usage. There is an anatomy you need before you build your router. Now connect this to the exam lens. If an answer says to inspect whether the assistant text sounds finished, be suspicious. That might be a useful human impression, but it is not the owning lever for the loop state. It is a scenario gives you a stop reason or a tool block. The stronger answer rolls from the state. That doesn't mean prompt wording is useless. Prompt wording matters, but prompt wording doesn't own the application loop. If the failure is that the application ends after the loop request, the owning layer is the application loop. If the failure is that the application loops forever after a tool result, the owning layer is also the application loop. If the failure is that the application cannot prove that what happened, the owning layer is logging and trace decision. Do not fix a state control problem with a louder instructions. Fix it at the layer that owns the failure. Your next action is simple. Keep the request anatomy cheat sheet open, then start lab 1 with a sample response. As you inspect it, ask 4 questions. What did the application send? What did Claude return? What stop state did Claude report? What is the next save application action? In module 2, we will use this anatomy to build the actual stop reason router. And stop guessing from assistant text. That is a shift from reading words to controlling the state.